Let's take another look at sensitivity and specificity of tests. We don't have perfect tests for detecting pathogens, and we often want to know just how well a test works and how much we could trust the results. So the sensitivity and specificity of a particular test are measures that we can consider. And many types of diagnostic tests are available that will have information that tells you about the sensitivity and the specificity of that particular test. We're going to look at a hypothetical example of some different tests that vary in terms of sensitivity and specificity. We're going to assume that we've got a group of people, some of whom have influenza A and others who don't. And we're going to test everybody in the group for influenza A. We've got some different tests, and our first test is both highly sensitive and highly specific for detection of influenza A. This test correctly identified all of the infected individuals, they had positive results, and all of the individuals who had negative results were not infected with influenza A. Now that's the best case scenario. Let's look at a couple of other ones. We can have a case where we've got a test that is less specific. And here, this test did correctly identify all of the people who have influenza A, but it incorrectly identified somebody as having influenza A who does not. So we've got a false positive occurring. And let's look at a test that would be less sensitive. Here we have identified a couple of the cases of influenza A, but one case was missed. We got a negative result for somebody who is infected, and this is an example of a false negative. And of course, our worst test would be both less sensitive and less specific. And in our example here, again, we've got a couple of the cases of influenza A correctly identified, but here we have somebody who has influenza A getting a negative result, and somebody who is not infected scoring positive. So we've got both false positives and false negatives.